kinds of things, which is great. Okay, so what kinds of operations can we then run on tuples? Well, they're going to have some similarity to the things that we've already seen in dealing with strings. So I now have inside of idle, I've got T1 and T2, they're two tuples. I can do concatenation. If I do T1 plus T2, interesting. Now, let's think about that. That addition operator we said was overloaded, and we know it can add together numbers, we know it can add together strings, and we know it basically does concatenation. That is, it stitches together things. So when I do T1 plus T2, it literally gives me the elements of T1 followed in order by the elements of T2. And you can see them there on the screen. There is 1, 2, 3, which are the elements of T1, followed by the tuple 1, 2, 3, and then the element 4. So concatenation just stitches them together, as we would have seen with strings. What else have we got? Well, we can index. We can go into a tuple and get out an element. And notice the syntax here. Given a tuple, and there it is, I've actually created something by adding or concatenating two tuples together. I'm going to use the square bracket, or the well, let's call it that, just the square parentheses or the square bracket, to tell us which element we want. So if we say, take the tuple T1 plus T2, my parens around it tell me it is a single tuple. I'm going to ask for the third element. And we can see where that makes sense. We already saw that for T1 plus T2, the 0th element was the numeral 1. The first element was the string 2. Second element was the number 3. The third element is, in fact, that tuple, the thing that I stitched together as I put it into it. So, again, indexing, just like before, starts at 0, and it simply walks down that order sequence to find the right element. What else could we do? Well, we know in strings we can slice, we can get out portions of strings. We can do the same things with tuples. So I could take the tuple T1 plus T2, there it is, and I can say, give me back the slice starting from the second element, indexing initially from 0, and completing just before the 5th element. And there it is. And if we look up above it, you can see it skips the 0th and first one, and has a 2nd, 3rd, and 4th, and it stops just before it gets to the 5th element, which of course we know there actually isn't one of. Great. So we're getting tuples having a lot of the power of strings, but just more general. There's one other operation that we can use, and that is a singleton. So what is a singleton? Well, how do I create just a single element of a tuple, or a tuple with just one element? And here I'm going to create it by saying I'm going to make T3 be the string 5 followed by a comma followed by a paren. And then I can do things like saying what's T1 plus T2 plus T3, and it is now added it at the end. And the question is, why do I have this funky little comment here? Why don't I just say that I want to have an open paren in the 5? Well, let's look at an example. Suppose I do that with a number, and I say, what's the value of this? Oh, right. The parens are telling me to group it together, so it's just the number 3. Whereas if I wanted to get a tuple with just a 3 in it, by giving the comma there, annoying as it is, it tells me that this is a tuple whose first element is 3, and it has no additional elements. And there we go. And then once I have that tuple, I can add it to other pieces, as I just did. Great. Got a set of operations that hold. What else can we do? Well, with strings, we could iterate over them. We could have a loop that walked down the string each element at a time. We can do the same thing with tuples. So let's look at an example. Here's a little piece of code that's going to find the common divisors of n1 and n2. It assumes that they're both positive integers, and it's going to give us back a tuple containing all the common divisors. How am I going to do that? Well, let's look at the code. I'm going to set up divisors initially to be, oh, look at that, the empty tuple. So this is telling me that divisors is a tuple that currently has no elements in it, that open close paren. Okay, then I'm going to run through a loop. I'm going to let I run from 1 up to the smaller of n1 and n2. Actually, that extra plus 1 there, make sure I get up to all of them. I'm going to have it run up to the smaller of the two. And then what am I going to do? I'm basically going to say, gee, if the remainder when I divide n1 by I is 0, and the remainder when I divide n2 by I is 0, then this is common divisor. So I'm going to add it in. And notice the form there. There it is again. I'm creating a tuple with just the element I. And I'm using the overloaded plus operator to add that to the end of the tuple that is what divisors currently points to. And when I'm done, I'm going to return divisors. Let's check it out and see what this does. So if I go over to my a little system over here, and I call find divisors, and let's run it on 20 and 100. Yeah, very nice. It gives me back a tuple. And those are, if you think about it, all the common divisors of 20 and 100. Great. Okay, so what else did I just do here? Well, I actually did a little loop over them, and that's what I wanted to get to. This is simply creating the tuple by walking through a sequence of ranges. But now let's look at the second part. Suppose I now say I'm going to set divs to be what I just did. I find divisors of 20 and 100. And we know what that is. And now I'd like to walk down that tuple, adding up all the numbers. Just get the sum of them. So I'm going to set total to 0. No big deal. And then for d in divs, I'm going to add d into total. And again, I'll remind that plus equal says it's the same as saying total plus d and set total equal to that. And if I do that, and I now say what's the value of total, there it is, 42. Okay, the key thing I want you to see is right here. This is now iterating over a tuple. And the for loop knows how to do that. Python's implementation basically says if this data type is a tuple, it's going to keep a little internal counter starting at 0 and walking along until it gets to the length of that tuple. And at each iteration through the loop, it is letting d, the loop variable, point to the value indicated by whatever that internal pointer points to within the tuple. So it's going to start off with d initially at 1, then 2, then 4, then 5, then 10, then 20, in the little example we saw here where divs was in fact that tuple. So what have we seen? Generalization of strings, an ordered sequence of elements where the elements can be anything. They're called tuples, and they have many of the same properties. We can index, we can slice, we can concatenate, we can loop over them. All really valuable properties, which means that the algorithms we've been writing, we might now be able to apply